Welcome to the second video about painting with light and color for artists. In this video, I will talk about more specific and advanced cases in which it is useful to understand how light works, and especially, I will touch on the topic of light diffusion and transparency of objects. And since today we're going to deal with more complex qualities of light, if you haven't seen the first video, I highly suggest you watch it to better understand the characteristics of light we will be talking about today. There's a link to it in the description. And in the last video, we talked about rays of light and how they work, and today we're going to talk about what they're made of and colors. A ray of light is made of waves of different colors. Each color has a different wavelength, and all we need to know about the wavelength of different colors is that they affect how well that color scatters. Red has the longest wavelength, and purple and blue have the shortest. Because of this, purple and blue scatter faster than other colors. But it's important to remember that our eyes can't see ultraviolet, so in this video, we'll ignore the violet rays and talk more about blue. You may remember from physics class that light refracts when it hits a denser surface. So imagine that a beam of light passes through the Earth's atmosphere and begins to refract slightly in particles of air. Roughly speaking, the warm colors of the spectrum keep moving forward, but the blue color refracts faster than other colors in the air molecules and disperses into the air. That's why we get blue sky. But then why do sunsets and sunrises have warm colors? Well, if you take away all the details of what's going on and oversimplify it, it goes something like this. As the sun approaches the horizon, the beam has to go through more atmosphere to reach us. Gradually, the warm colors of the spectrum begin to disperse too. And to answer your possible question about why every sunset and every sunrise is different, it happens because so many factors affect the density of the atmosphere. Humidity and weather on a particular day, the presence or absence of clouds, air pollution, and so on. And the density of the atmosphere in turn affects how quickly the colors of the spectrum will disperse and to what extent they will have time to do so. Just remember that the denser the atmosphere, the more likely the warm colors of the spectrum will have time to scatter and the red will have time to show itself. And if you think about it a little bit, it makes sense why sunrises usually look cooler than sunsets. It's just that in most situations, especially in big cities, the air is cleaner in the mornings than in the evenings. So in the mornings, the warm colors of the spectrum don't have enough time to disperse. And respectively, if you notice when there are like fires and there is a lot of smoke in the air and the sun appear to look more red. That's again because the atmosphere gets denser and red has time to disperse. Water is somewhat similar to air in the sense that it's generally transparent. Depending on the density and composition of the water though, as well as the color of the bottom and the remoteness of the bottom, its color will change. So we cannot say for sure that water is always blue or it's always brown or turquoise. It depends on the situation and on the environment. But what we do know for sure is that underwater, the light will continue to radiate for a while, but because water is much denser than air, some of the light will scatter over time, and the underwater light will therefore look more and more like diffuse light. Another thing that will happen is as we go deeper and farther away from the surface, colors with short wavelengths, instead of scattering as in air, will be absorbed and become weaker. Red objects will begin to lose saturation first, followed by other warm colors, until only shades of blue remain. In theory, the same thing happens in air, just to a lesser degree. This is maybe why very distant objects gradually turn into blue silhouettes. Another thing that happens on the surface of water is the refraction of light. As you remember, when light enters a space with a different density, it refracts, and because of that, plus the fact that the surface of the water is not usually perfectly flat, similar patterns can form on the bottom. With the dimming of light and depth, they disappear, but in sunny weather and in shallow water, they can be noticed. To calculate what exactly these forms will look like is very difficult. It depends on the shape and size of the waves on the surface, so I would just suggest finding good reference. To find them, I can recommend checking out an Instagram of an underwater Korean studio or photographer, I'm not really sure. They have underwater photos with different types of lighting and they look beautiful. So I'm actually going to stop here because I don't want to overload you with information, and I'll continue in part 3 of this series. In the next video, I will tell you how to understand and work with reflections on transparent surfaces like water and glass, and how translucency works. That last video is going to be bomb.com because we can finally get into the deep stuff. And meanwhile, draw and don't slouch.